Our lives are increasingly dependent on technology to work, from the way we travel to how we grow food, and of course, the device you're watching this on. But the more tech that's in our lives, the more susceptible we are to the whims of the sun.
The different industries have different ways of responding. For example, the power grids have to be concerned about the potential that energy will enter the grid and create a bias that could overwhelm the transformers. Aviation is impacted primarily because the long-range communications using high-frequency radio relies on the state of the ionosphere, and the ionosphere is disturbed by these space weather storms, which means that those high-frequency communications are disrupted.
Space weather is how researchers and forecasters describe the various impacts of the sun. Those include violent eruptions called coronal mass ejections. They can interfere with satellites, power grids, and even impact astronaut safety. That's where this latest satellite from the National Oceanic and Atmospheric Administration comes in. It's called the Space Weather Follow-On Lagrange 1, or SWFO-L1 for short. It's the first NOAA spacecraft purpose-built as an early warning system for space weather. The Lagrange 1 in its name is where the satellite will operate. L1 is a stable, fixed point in space, about 1 million miles away from Earth, that sits between our planet and the Sun. Richard Ullman, the director of NOAA's Space Weather Observations Office, picks it up from there.
When an event comes off the sun, a coronal mass ejection, depending on how fast it is, and of course the track, whether it's coming towards the Earth, it could be a super fast one is 12 hours. More typical is 2 to 3 days. So we get a couple days warning. But we don't actually know how strong that storm is until we see it at the Lagrange point 1. 1 million miles is a far distance, but remember the sun is 93 million miles from Earth. So at these speeds, what that means is we have about 15 to 45 minute warning of exactly how strong that is.
That may not seem like a lot of time in the grand scheme of things, but it could make a big difference to key industries. Let's go back to Ullman's example of power companies.
So they get a couple from 12 hours to 2 to 3 days warning something might be coming. And so at that point, they might choose to delay maintenance or change their staffing profile. But then at the few moments before, they're able to get how strong we think this is going to be and perhaps even what regions of the Earth it might impact. And so that they can take preventative actions to perhaps turn off sections of the grid or be prepared for these potential overloads.
Dr. Joseph Westlake is the director of NASA's Science Mission Directorate's Heliophysics Division. He pointed to the solar storms of 2024, which provided unusually widespread views of the auroras as a key turning point for folks. Westlake says that event brought the impacts of the sun down to earth for a lot of people, both the beauty and the potential economic impacts.
We found for the first time that agriculture in the Midwest has been affected by space weather. I never thought that I would be in a conversation with some of our agriculture folks as a heliophysicist thinking about, how the sun impacts us when they say, my GPS systems, my precision location systems were affected by the May solar storms. And I missed part of the planting season because my systems were inoperable for that time. It's the first time we have seen that. As the American public becomes more and more technologically savvy, as we become more and more reliant on things like GPS and space-based communications, I think it becomes more and more of a reality that every company is now a space weather company. Every industry now is affected by space weather, and every American is affected by these impacts.
But SWFO isn't flying solo. It's hitching a ride to Lagrange point 1 alongside NASA's Interstellar Mapping and Acceleration Probe, or IMAP, and the Carruthers GeoCorona Observatory. Both spacecraft have their own unique missions studying the impact of the sun. Following launch, the trio will take the rest of the year to make the trip out to L1, arriving around January 2026. Ullman says that SWFO should be finished with its calibration and commissioning by early next year, and he expects it to be fully operational in the spring.
Unlike the other satellites that are being launched, the IMAP and Carruthers, which are science missions, they're research science missions, we are a science application mission. So we are looking at the same phenomena for the application of being prepared for the space weather that's going to impact us. We're hoping that these IMAP and Carothers will improve our knowledge and make us able to make better forecasts. But what we're doing here is the operational forecast, the day-to-day.
The spacecraft itself was built by BAE Systems in Colorado and features a suite of 4 science instruments. Spaceflight Now was able to see the SWFO-L1 up close after it finished its fueling campaign last August. Dr. Dimitrios Vassialdis, the SWFO scientist and former NASA research scientist, gave an overview of the spacecraft's instruments.
The most visible part is the magnetometer boom. That's a large cylinder that you see on your left. That will extend all the way to 15 meters, 5 meters, 15 feet out, and that will measure the magnetic field as it's streaming past the spacecraft. Then we have additional instruments such as 3 imaging/sensor instruments. One of them is a telescope that looks at the sun, and that in particular looks at the solar corona. And 2 others are particle sensors. These are on the opposite side, so they're not exactly visible, but you can think of them as also pointing towards the sun. They will measure the plasma as it streams also past the spacecraft, and the particles that are also emitted from the sun.
The SWFO-L1 spacecraft is designed with a 5-year mission in mind, but it has enough fuel on board to potentially operate for a decade or more. Ullman says Congress approved $692.8 million for the total mission cost. That includes $635 million for the spacecraft itself, as well as another Coronagraph that launched on the GOES East satellite back in June 2024. The cost also extends out to the ground elements that will be used here as well as on successor missions. One of those is already in the works. It's called Vigil, and it will operate at Lagrange Point 5 through a partnership with the European Space Agency.
Our contribution to the Vigil mission as a part of our partnership is a coronagraph, same model coronagraph that we have on SWFO. And so that will give us a stereoscopic view of those coronal mass ejections. L5 is behind Earth, 60 degrees. L4 is 60 degrees the other direction. When we're looking at a stereoscopic view, it really doesn't matter which direction, which side we're looking at. We want a side view. L5 is got some advantages, being able to see sunspots and things before they rotate into pointing at the Earth. L4 has other advantages, but L5 is the next opportunity, and that's why we're going there.
While ESA won't be launching the Vigil mission until 2031, Ullman says NOAA is already working on the successor to both it and SWFO.
We're also have already started the next iteration of the same observing capabilities with what we are calling the Solar Project, which is the next 2 spacecraft that are like SWFO to go to the Lagrange Point 1. The first of those is planned to be launched in 2029. And at that point, that gives us more resiliency on the really important Sun-Earth line, and it provides for continuity into the future.
Ullman says he and the NOAA team are excited to finally be on the cusp of launching about 5 years after this mission was first conceived. He says this will be a critical service for not only those in the United States, but also to others around the world.
We get the data down within 5 minutes for solar weather, and within 15 minutes or 30 minutes for the coronal mass ejections. That operational cadence is well improved from the historic legacy research missions, which had a very different purpose, which was basic research. It's important to know that NOAA is committed to space weather observation and making sure that the nation is prepared for those events that come from the sun that affect our lives and our economies.
Reporting for Spaceflight Now, I'm Will Robinson Smith.